Hi, today let's talk about how to choose a database in a system design interview. If you haven't already, check out the new series on system design interview I'm working on down in the description below. Let's jump right into it. At some point during a system design interview, you will need to store data, and in order to do that, you will need to choose a database system. Such systems are split into SQL and NoSQL databases. It's important to know the difference between these two in order to be able to choose the best one for the system being designed. Each of them have their own strengths and weaknesses, and you should choose based on the use cases. We'll look at the differences and I will show you some use cases using examples. Let's start by looking at SQL. SQL stands for Structured Query Language. SQL databases are table-based, where tables have relations amongst each other. NoSQL databases, on the other hand, are categorized into key value, column store, graph DBs, or document store. SQL databases allow for easy vertical scaling, while NoSQL DBs are horizontally scalable. SQL DBs are relational databases. Relational means that all data is stored in a table format, and these tables are connected to each other, and these connections are called relations. Here is an example of two tables related to each other. We have a customer entity table and an order entity table with the respective attributes. Each table has a primary key attribute which is unique for each entry of the table. To connect these two tables, we use a foreign key in order table which references a primary key in customer table. We can see that SQL relational DBs have structured data, and it is important that whenever new data is inserted, these constraints need to be maintained. SQL DBs are ACID compliant, which means that transactions are atomic, consistent, isolated, and durable. There are some drawbacks with SQL databases. The main one being that table structures must be created in advance, which can be time consuming. These kinds of databases are hard to scale horizontally because of the relations between the tables. So when additional processing power is required, these kind of DBs are vertically scaled by adding additional hardware, which is costly and harder compared to just provisioning extra servers. Let's now look into NoSQL databases. There are various benefits in using NoSQL DBs. These kind of databases are better suited for unstructured data, which means they are more flexible and simpler to set up as there are no relations to take care of. The most common NoSQL DBs are key value stores and document store databases. Data sharding is easier to achieve with these kind of databases. Therefore, they are better suited for distributed storage, and they offer easier horizontal scaling. There are some drawbacks in using NoSQL databases. Generally, there is a loss of consistency as these databases are designed for a distributed usage. What this means is that when the system writes data in a particular shard of the distributed NoSQL database, it takes some time, although small, to propagate over all the other replicas, which introduces the concept of these DBs being eventually consistent. Let's now look at a system design question and see which kind of DBs would be most appropriate for each operation of the system. Let's say you are asked to design an e-commerce system where a customer can place orders, contact customer service, and receive confirmation emails for each order they place. Let's quickly analyze this problem and see which kind of data we will need to store. The customer will be navigating through our website, so we will need to create a session for our customer and save this information somewhere. User sessions are generally key value pair data. They are read extremely frequently, updated often, and do not require persistence. The ideal database for this would be an in-memory database instance like Redis. The next action our customer can perform is placing an order and contacting customer service. In both cases, we need to store information about the order a customer has placed so that we can perform different operations with it, such as sending a confirmation email with order details, saving the order for auditing and accounting purposes, and giving the opportunity to customer service agents to read order details when dealing with customer queries. As you might have noticed, this data might be read multiple times during long time spans. Hence, we want to persist this data using a SQL relational DB. Order details are a perfect candidate to be stored in a relational database, and its ACID property makes it perfect for this use case. Hopefully you found this video useful. If you have any suggestions or feedback, leave it in the comment box below. If you found this video useful, please like and subscribe. Also check out my YouTube channel, you're gonna find many more LeetCode questions and other videos that I hope you're gonna find useful to prepare for your technical interviews. Thank you.